My name is Julia Phillips, and I'm talking today in my role as the chair of the Committee on Science and Engineering Policy of the National Science Board. And what I'm going to talk about are some thoughts on metrics for judging the success of the NNI that have been inspired by the science and engineering indicators published by the National Science Foundation and the National Science Board every 2 years. The most recent edition was released in 2020. The National Science Board publishes the science and engineering indicators as a result of a statutory requirement, which requires the transmission biennially of these indicators to the President and Congress. And the intent is to report on the state of science and engineering in the United States and in a global context. The indicators are both policy relevant as well as policy neutral. And I would refer you to the URL, the web page for the indicators that is indicated at the bottom of this slide. There is a wealth of information there, both in the prepared reports as well as in a tremendous amount of data that is not actually discussed in the written reports. And what I'm going to do is talk about some possible metrics derived from the indicators, possibly other sources that might be tailored specifically to looking at the effect and impact of the NNI. First, let's look at the big picture, which is global investments in research and development, as shown in this graph, again taken from Indicators 2020. And one sees the tremendous change in R&D expenditures by different countries, the US being in red, China being in purple, other major investors shown in the other colors. And one sees some very important trends, a general and pretty steady rise in investment by the US, a very dramatic increase in investment by China. This is, of course, for all of R&D. And when one thinks about what one might look at for NNI, one comes up with a few possible metrics. For example, what are the trends in total research and development investment for NNI relevant fields? And in different countries, the US as well as other countries in other regions. Second, one might break this down and look at trends in basic, applied, and development research and development in different regions and countries, because that breakdown is very different depending on which country or region you are talking about. The second thing that one might look at that is inspired by some of the information from indicators is the industry output in high R&D intensive industries. These are industries where R&D plays a huge role in the products that are actually produced. And again, one sees, if you look at all of the high R&D intensive industry output, that there is an evolution in terms of how much and what proportion of that output is by different countries and different regions. These are industries such as aircraft, pharmaceuticals, and that sort of thing. When one thinks now about how that might translate to NNI, there are a couple of things that one might look at. For example, what are the trends for global NNI output in NNI intensive industries? And second, that is sort of a lagging indicator, if you like, because there is a lot of knowledge that is produced before the industrial output occurs. So what are the trends for global knowledge production? Again, looking country by country or region by region. And here we're talking about publications and patents. These are not the whole story, of course, but they are important indicators of how the US is doing in NNI relevant industries and potentially things that should be tracked for looking at the impact of NNI. Finally, turning to education and workforce. If you look at the race and ethnicity of U.S. science and engineering degree recipients at different levels, ranging all the way from associate's degree to doctoral degree, you see that the demographics do not reflect the demographics of the U.S. population, which is shown in the top bar. Just for clarity, the light blue is for white, orange is for Black or African American, dark blue is for Hispanic, yellow is for Asian, and so forth. So the U.S. is not doing a good job in science and engineering as a whole in having its workforce reflect the diversity of the U.S. population. That raises the question of how are the demographics of NNI-related degree recipients, and how are those changing over time? Are we making progress in making the NNI workforce more representative of the U.S. population? Possible metrics include what are trends in the diversity of degree recipients at all levels in NNI-relevant fields? What is the diversity of degree recipients that are funded by NNI programs? In other words, you can actually potentially look at the impact of NNI related investments by the federal government. Finally, is the degree completion rate as a function of various diversity access for NNI funded students? Is it changing, and how is it changing? Degree completion is very different across the board for science and engineering students, depending on various components of diversity. And so it's important to understand whether NNI is doing better or worse. And then one can ask the same questions about women as compared with men. And just as one example, for the materials degree recipients, I looked up some numbers, again, using the science and engineering indicators as a source. And actually, it turns out U.S. materials degree recipients are even less diverse than the average science and engineering recipients. So that might be an indicator of what one would see if one looked at NNI relevant degree recipients. And staying on workforce, one should probably also be looking at foreign-born workers in U.S. science and engineering. There's a wealth of data on this in indicators, and as you can see, the proportion of foreign-born degree recipients varies tremendously depending on the degree field. Turning to NNI, one could ask, what is the percentage of foreign-born workers in NNI-intensive industries, and how is that percentage changing? That gives you an indication of how attractive the U.S. remains as a magnet for top foreign-born talent in the NNI workforce. So, in summary, I think there are many metrics inspired by the science and engineering indicators that could be helpful in tracking the progress and the impact of NNI. International and national trends in R&D investment in NNI-related fields, both total as well as broken down by the type of investment. International and national trends in NNI-intensive industry output. You'll have to pay attention to where value is added in global chains, but that is something that is done in the indicators. International and national trends in NNI-relevant knowledge production, publications, and patents. Trends in attraction and retention of a diverse NNI-relevant workforce at all degree levels, and the impact of NNI programs on increasing retention and diversity. And finally, what are the trends in attracting and retaining top foreign-born talent in NNI-relevant fields and the impact of NNI programs on that attraction and retention?